So we're going to continue talking about Unit 3 chemical names, and more specifically, we're going to talk about ions today. First thing that we need to know is how do ionic bonds happen, and that is through the electrostatic attraction between a metal and a non-metal. Meaning we need to be able to look at our periodic table, hint, hint, nudge, nudge, cough, cough, that we need to look at a periodic table and be able to identify what elements on the periodic table are a metal and which ones are considered to be a non-metal. If we look at our periodic table, we will remember from hopefully last unit that we can see that the majority of the periodic table is metals, meaning the majority of the bonds that we find or the things that we have to name will become ionic compounds. And they don't have to always have like a metal like we would think, such as copper or iron. However, they can have others. Now, when we go to do the naming on these, this is what we actually spend the majority of the naming unit on, is naming ionic compounds. When it comes to talking about the bonds, it's quite the opposite actually. It's the other way around. So when we look at these, it will be we take it very step by step, talking about the monatomic ions. Then on Monday we'll talk about the transition metals and some of the other odd ones that are out there because they have some nifty things. So what is a monoatomic ion? They are the names and formulas for ions that are formed by one element. That one element can come from a number of different things. And so when we look at that, it is forming based on the fact that we have a gain or loss of electrons. So we have to be very mindful that it's a gain or loss of electrons, and it is never the gain or loss of a proton. Protons define what that element is, and therefore never change. I don't know if I can stress that enough, in that the number of protons never changes. If a element gains or loses anything, it's the number of electrons, because the number of protons defines what that element is. So the elements found on the left-hand side of the periodic table tend to blank their electrons. Do they gain electrons, lose electrons, keep their electrons, or share their electrons on the left-hand side of the periodic table? Elements on the left-hand side of the periodic table tend to lose electrons because the metals are on the left-hand side and they lose their electrons to gain a positive charge. How do we write that? Well, we write that in a couple of different manners. A cation is a positively charged ion formed by the loss of electrons. Now, we use pedarium so that we don't, have to get too specific how we write it. How it is written can change a little bit. Instead of having the 1 and the plus in superscript, we can also have it written with just the positive in superscript as well. If we have any number greater than 1, we have to put the number in with that. And so if potassium had a charge of a positive 6, that is what we would do. Now an anion is a negatively charged ion formed by the gaining of electrons. That's why it has a negative charge, because the electrons are negative. And it is written with the charge in a superscript as well. If, say, we have a compound or an element, that has a -1 charge, it would be written as that, or it could also be written as just a negative as well. When we write the formula, we write the symbol for the elements. We have to be able to identify our elements and know the symbols, followed by the charge and of that ion in superscript. Now, the periodic table that we use for our class has a lot of these charges given to you in the upper right-hand corner of the periodic table. Now, how do we remember which ones are cations and which ones are anions? Well, cats have paws, and therefore they have a positive charge. Anions are usually a negative thing, so if you are anti-homework, I don't know why anybody would be, but if you are anti-homework, you would think that homework is a negative thing. And so we have those help us, word association to help us know which ones are positive and which ones are negative. Now, for this class, it is going to make life easy for you, again, that the main group elements for groups 1, 2, and 13 will always form cations. Now, which cations do they form? That's a lot based on the last number in the group number. Based on that, the trend is group 1 forms a positive 1 charge. Group 2 forms a positive 2 charge. And group 13 will form a positive 3 charge. If we skip group 14, and there's reasons why we will skip 14 for a lot of things. We'll talk about that later. And we talk about the main group nonmetals, more specifically groups 15, 16, and 17 will form anions. Now, if we look on our periodic table, we'll see something very interesting happening. And that is, if we look really closely at, say, nitrogen, nitrogen has a -3 and a number of positives. For the class that I teach is in high school, we do not worry about the positive charges for nitrogen. We will only worry about the negative charge. As same with phosphorus, sulfur, chlorine will be another one as well. Even though they might have positive charges, we do not worry about that. We only worry about the fact that if they are in a non-metal, they have a negative charge. Okay? Now, more specifically, they have very trendy charges as well. Group 17 form a -1 charge. Why? Because they're 1 electron away from having the electron configuration the same as a noble gas. Group 16 forms a -2 charge. Why? Because it's 2 electrons away from having an electron configuration similar to that of a noble gas. And group 15 all form a -3 charge because, again, they're 3 electrons away from forming an electron configuration similar to that of a noble gas. So it's that octet rule that drives which ones are which. Now, why does group 14 not have that trend? Well, group 14 could lose 4 electrons and have an electron configuration of a noble gas, or it can gain electrons and have an electron configuration of a noble gas. So it will kind of do a little bit of whatever it wants to in the gaining or losing of electrons. When we name main group monoatomic cations, all we have to do, especially for cations, and this is very specific, for monoatomic cations, all you have to do is add the word ion to the end of the name. That indicates that you're not talking about the metal itself. Instead, you're talking about the cation, the ion of that metal. If you just said calcium, most chemists, when you're speaking that language, would think that you're talking about the calcium metal. But if instead you wanted to say the calcium ion, now you're speaking a different word, meaning you're talking about the calcium ion and that it has a positive 2 charge. That's how we're able to differentiate between ions in the metal itself. How do we do the same thing for anions? Well, for anions, we need to change the ending of the element to IDE and then add ion to the end of it. That allows us to determine whether or not you're talking about an ion or something that is part of a bigger compound. Case in point, fluoride. Fluoride has the ending of IDE, indicating that it's a negative, but it doesn't say, we don't say ion at the end of that when we talk about getting your fluoride at the dentist, because it's not the fluoride ion that you're receiving at the dentist for your teeth. You are receiving a fluoride-based compound that is helping you. If you were getting the fluoride ion, that would mean that you were getting the F with a -1 charge. And so therefore, we're able to differentiate what is actually being talked about using these little ways, adding an ion or the IDE. And the IDE really does indicate that it is a negative ion, because none of the cations get the IDE ending when they are part of an ion. They never get the IDE because, again, that is sole indication that you're dealing with a non-metal. So let's try some out. Na is the symbol for what? Na is the symbol for sodium. And we add, because it's positive, all we have to do is add ion at the end of it. In the next example, we have the magnesium ion. Magnesium symbol is Mg. The charge that we have, because it's in group 2, it has a positive 2 charge. Al is the symbol for aluminum. And it has what charge? The charge is 3. Therefore, positive more specifically, and that means all we add is ion to the end. Yes, C is for carbon. It does not have the ending of IDE, therefore, what is the charge that we have? Because it doesn't have the ending of an IDE, we actually have two correct answers. It can be a +4 or a +2. Now again, carbide, the symbol is still going to be C, because the ending is IDE. That means that we have what charge? It is a -4. The only way we're going to know that is by looking at our periodic table. O is the symbol for what? O is the symbol for oxygen. We have to change the ending to IDE because it is a negative. And then we add ion. Nitride ion. Nitride has the symbol for nitride is N. And therefore, because it has an ending of IDE, that means it's going to have what charge? And we see that on the periodic table, it has a -3 charge. Br is the symbol for what? It's bromide, because it's negative. Bromide ion. And there we go for monoatomic ions.